Hey, what's up, guys? So who here has played Kahoot? All right, lots of people. What is it? What is it? What is it, Alex?
It's a game where you can answer questions and maybe win a prize.
Exactly. I got a bunch of free T-shirts. No, I'm just joking. They're $20 actually, but I'll give a free T-shirt out though. We got free stickers, but this is basically Kahoot. I just didn't feel like paying for it, so I just got a free version that some 15-year-old kid made. It's really good, by the way. And let's see. Hold on. Let me go to this link. So clickz.org. Okay, so it's even got some fancy music too, but pretty dope, right? So if you go over to it's quickz.org, and then you go. There you go. There's Alex, and then you want to type in that link right there, that number, and then put in your name and put whatever you want, whatever avatar you want. Everyone's using the same avatar. You guys can be more creative. Oh wow. We got 16 people so far, 19.
Wow. Oh, that's where I put my name.
I know, bro. This is awesome. Okay. You guys ready? You guys get ready. Okay. I put the parrot on there to distract you guys, you know. Yes! We got a lot of people that got it right. Awesome. Alright, let's go to the next one. Alright. What is it, Alex?
I don't know.
$1 million question, man. You want to phone a buddy? I'll phone you. Funny. You funny, man. Okay. Okay, hypertext markup language. Ooh, Ryan. Wait, Ryan. You're killing it, bro. And Jordan, you too. Okay. Someone made themselves Zoom started. Okay, who's making the web standards? Is it Google, Microsoft, Worldwide Consortium, or Mozilla? What do you guys think? Alright, so dang man, Ryan, you're killing it, man. Just Ryan's like, I'm gonna win everything, man. It's all me.
It's the only thing I'm here for.
He's like, I'm just here for the swag. Okay, what does CSS stand for? Is it creative style sheets, computer style sheets, or colorful style sheets, or cascading style sheets? Did you figure it out, Alex? There's a bunch of colors, I believe in you, bro. Okay, Ryan again, man. He's doing it. Someone named themselves Zoom started. That's kind of funny.
Yeah, I answered the first one right, but it gave me incorrect.
Oh, really? Okay, this is a harder one now. This one requires a little bit more JavaScript knowledge.
I'm sure you got
Ryan again, man.
like
And Cat's coming up. Who's Cat? Who's Cat here? Cat's getting close. Can you maintain first place, Ryan? Still one more question. I think one or two more questions. yeah. This is all JavaScript, by the way, because I'm a JavaScript developer. I don't know any other languages that well, so.
I keep trying to touch Rust and then I get scared.
I know. My C# is super rusty. My Python, don't ask me to look at it because I don't remember how to write it. I'll have to look at GitHub and look at some like repository examples to refresh my mind. Alright, true. Because it's a truthy statement, so it's true.
I just got my 3s and my 7s.
Oh, you're still there. Okay, I think there's one more. Maybe I think this is the last one? Okay. I literally copied this off W3C just so I didn't make a typo. I was like, I couldn't trust my own judgment. Like, do I actually know the answer to this question?
The right answer's not on there.
Exactly. You have to look outside the box.
Non-strict equality is never the right answer.
Exactly.
X equals. Oh, that's all JavaScript, by the way. Maybe in a different language it's different, but. Hey, look at you, Ryan. Cat's moving up though. I'm gonna see if Cat can win though. Let's see. Oh wait, was that it? Okay, Ryan, your first place, man.
Hey,
what size t-shirt do you wear?
for the free shirt.
What size t-shirt do you wear, bro?
A medium.
Perfect. I just bought a ton of medium. Okay. Bro, I'm gonna. Well, if I throw it, yeah, I might hit that beer. So there you go, bro.
Thanks, bro.
Yeah, go run!
Yeah, go Ryan, bro. Maybe next time, Cat. Maybe next time, Cat. You were really close though, and Jordan, you're really good too. And I just had to see where Alex is at.
Wait, what?
I'm just joking. I just picked on you, bro.
I got the last two.
Yeah, now you got some questions, man. That's why we're here, bro. We're learning. Okay.
So our goal is to have the tech community to provide a community for you to connect with other like-minded people that belong to your tribe. I was about half a year with Vincent, and we went to Orlando for a very similar meetup, like the one we're having today, but without presentations. We'll just chill and have a beer. And then on the way back, Vincent was thinking loudly that we don't have that in Tampa. We used to have it before COVID, but we don't have it anymore. And an idea was born. And being the hardworking guy Vincent is, I knew that idea was not to stay in his head for long, and is going to be implemented on the ground. And sure enough, he did. Only a month later, we were chilling and having a beer in one of the places in Tampa. And that was probably the first time post-COVID that something like that happened. And then it was taken to a next level, and we started having presentations. Nowadays, roughly we have once a month like this, and once a month just chill and have a beer. So this is what we aim to, and it wouldn't have been possible without you wonderful people coming here. So thank you so much for being here tonight. These are some photos from previous events. And now for the first talk. You'll have two main talks today.
Oh. Just keep hitting. There you go.
All right. So for the first talk, let me invite Lydia. You ready? Okay, so we have these guys offered for you: t-shirts, free stickers, free. Feel free to grab some of them. I have one of the stickers.
And then that's the last slide.
Yes, you can follow up on all social medias, including meetup.com.
So feel free to take a picture of that. If you guys want to look it up. But we have a website, tampadevs.com, that has everything on there too, including like the meetup links, the Slack links, the social media links, everything.
So my name's Lydia, and I'm giving a presentation on Git. And just show of hands, how many of you guys use Git every day already? All right, yeah, kind of what I figured. How many of you guys have ever screwed up a Git repository so bad that you had to totally throw it away and just like download it again?
Yes.
Yes, that is why I'm giving this talk. So when I first started working as a dev, I kind of had my tried and true couple of commands that I used, right? I was like, git add felt really cool, commit, whatever. And I had my certain commands, and if I ran them in a particular order and everything went exactly as planned, then my life was really good. But if stuff got screwed up, then I would get really nervous and call Jordan or my tech leader forever and be like, I need help, I screwed it up, I can't figure it out. And that's because I never really understood how Git worked. So if you take the time to understand how Git is actually handling data internally, and you take the time to build up a mental model around how it works, then your day-to-day life working with Git gets so much easier. And that's why I wanted to give this talk. So hopefully after this talk, you'll have a mental model, you'll understand how the data is represented, and then we're also going to look at some of the more common commands, as well as interactive rebase, which some would say is like a more advanced command, but it's definitely my Swiss Army knife that I use for getting out of all kinds of situations that I don't want to be in. So first of all, what is Git? And I actually want to ask, does anybody here want to take a stab at telling me what Git is? Yes.
Version history?
Yes. Version history. Perfect. And you can see here that I have that it's fully distributed. So that's really key. It was created back in 2005 by the Linux development community, and specifically by Linus Torvalds. And just to kind of set your mind in the time frame of that time, in 2005, he was developing the Linux kernel, which today is an absolutely massive project with thousands of developers all across the world contributing. But SCMs looked really different at that time. And in fact, most of them were using a centralized model. So has anybody used anything other than Git? Yes. Was it centralized? Just raise your hand for yes. Okay, cool. Yes. Subversion, right? Do any of you guys that have experience with that want to talk about what it was like to use a centralized version? Or a centralized model, I mean? Like, terrible? Okay, yeah, it was, especially for open source, like it really does not work well. So this diagram right here is representing a centralized model, and it's very obvious. We have one code repository in the middle, indicated by the little green stack of stuff, and then you have all of the collaborators. So there's one repo, and anytime that you want to work on some files, you have to check them out from the repo, and then you can publish your changes only once you're done, and at that point, everyone can see what you've done. It's a really slow process. Merging, I heard, took like a week of planning. I never personally had to work with any of these. And there was this idea of branching, like you could technically branch, but there's only one code repository, so only a couple of people could mess with it. So you would actually have to go and ask someone to create you a branch. And this created a lot of politics around who had permissions to mess with the code repository. It was really slow, PRs were very painful. You also, I believe, couldn't run your test against the entire repository until your code had been merged. So like, this is not a good development experience, right? And especially for an open source project that was growing, being the Linux kernel, like this just was not working for Linus Torvalds, obviously. He was using Bitkeeper at the time, which was a decentralized model at least, but he had some concerns around data integrity and performance to the point where he was like, this, like I have to stop and solve this problem before I can continue on with the kernel project. So he actually put the Linux kernel completely on hold for about 10 days and took that time to create Git. And it's really cool because, I know, just 10 days, no big deal. But even cooler is that after the first day and a half or so, Git was actually tracking itself. So if you are interested and want to see the history of Git, you can look at Git's Git history, and it takes you almost all the way back to the beginning. So comparing that with a decentralized model, which is what this diagram represents, here you can see that every developer essentially has their own copy of the code base, and that's what happens when you run the git clone command. You're going to get your own copy as well as the history. So branching is no longer a problem. You have your own sandbox, so you just create your own branch. You can make whatever kind of mess you want to make. You can mess things up. It absolutely does not matter. Like, no one sees it. That also meant that parallelized development was possible because you could pull and commit often, and you could share between developers. Merge commits were obviously, or merge conflicts are obviously still a problem, but they're much more manageable because you're able to share data more frequently and more easily. Also notable here is that all of these repositories are actually equal. So you have redundancies, which is the escape hash that we talked about before, where if you mess it up, you can just throw yours away and you can re-download it. I do kind of want to point out that the decentralized model that I'm showing here, you probably see the little GitHub logo or whatever it is beside the middle one. So that middle one kind of like appears to be more important, but this isn't, you don't have to work with a hosting service in order to use Git. So you have GitHub and you have Bitbucket, and they're used for hosting Git repositories, but this isn't the only way to do it. And actually back when, like early on, like 2007-ish or whatever, I don't know what he's doing now, but for the Linux kernel, Linus Torvalds said that he did not want to use those hosting services because the UI of them actually kind of encouraged bad commit messages. So he wasn't really a fan. His structure for how he managed that project, or how he manages that project, was more of a tree where he is at the top and everyone really just cares about his repository, obviously. But then he has his, what he calls his network of trusted developers, like people that he says are smart and not dumb or ugly. That's what he says about other people. It's very entertaining. And so he actually splits it up based off of their expertise. So for different subsystems of the kernel, you might have one person who controls the repo for USB. So then those people have their trusted network, and then those people have their trusted network. So you end up with these layers of filters. So if you're a developer and you're wanting to get code merged in, it's going to have to go through these different layers, and eventually maybe it would make its way up to him. But yeah, so my whole point being, what you're looking at is GitHub, and it looks like that central repository is more important, but really decentralized just means that you can share between different repos. All the repos are equal, and you have the redundancies of the fact that you can share. So it's kind of like the Wild West. And that brings me to the point of data integrity. How do you know if you download someone else's code that you're getting what you're expecting to get? And I'm sure you guys are familiar with this little, 8-character hexadecimal string here, right? This is a commit hash. I'm sure you've seen it. But did you know that it's actually part of a larger 40-character hexadecimal string, which is actually a SHA-1 hash? When you make a commit, Git computes the SHA-1 hash of the commit data, and then that gives you this fixed size value, which is called a message digest. And the message digest essentially guarantees the entire history. So if your repository were to get corrupted, as long as you know the commit hash that you want, then you could re-download it, aka clone it, and you would have absolute certainty that you were getting exactly what you expected. And we'll look a little bit deeper at how that works later on. So now that we've talked about the history and kind of the problem that Git was solving, I want to go into the mental model. And this structure is probably very basic. I'm sure you've seen this. It's a file structure, right? At the top, we have root, and this is your project directory that you want to track with Git. And then we have foo, which is just a folder, which Git refers to as trees. And then we have two files, which Git refers to files as blobs. And now let's say that we're going to take a snapshot of that directory, the project directory, at just some point in time. Maybe it has a timestamp. This blue dot is representing the state of the directory. And then the next day, after some changes, we take another snapshot. And then we do it again. So at this point, we have a history of snapshots. And it's a linear history, and each snapshot has some metadata that says my parent was the snapshot before me. So it doesn't have to be linear with Git though. You could pick any given snapshot and make a branch off of it, create a new child essentially off of it. And this is branching where you have two or multiple different snapshots that all point back to the same parent. So you probably recognize this from having your main line of development and then maybe a bug fix or some branch that you're working on. But at some point you want to bring it all back together. And that is where merging comes in. So this example is a basic commit called, a basic merge, which would be like a three-way merge where Git's going to actually create a new snapshot. And it's going to pull in the bug fix. So in this new snapshot, you have both your feature and you have the bug fix, which is ultimately what you want. So these two diagrams, the snapshots of the files and folders, and then also the history of the commits, these are kind of our mental model. And you might look at the snapshots and you're like, oh, that snapshot, that is the directory that I took a snapshot of. But it's a little bit more than that. It also has some metadata around it, like an author and a commit message and maybe like a timestamp. So now that we have these three things, like our snapshots, our files, and our folders, how are they actually represented in Git? And Git defines these three types of objects. And everything I'm about to talk about is pseudocode. So if you're a JavaScript developer, like throw out the idea of a JavaScript object. Everything is pseudo. So we have blobs, which are just files. They're essentially just an array of bytes. We have trees, which are folders. And a tree is going to be a mapping that is a string. And then the value is either a tree or a blob. So the string is going to be either the file name or the subdirectory name. And then the tree is the subdirectory itself, or the blob is a file. And then we have the commit object, which is just a structure that has the metadata, like the parents. And note that I say parents plural because if it's a linear history, the commit is only going to have one parent, but if it's a merge commit, remember it has two parents. The author, the message, that's just metadata, and then like the main piece of it is the snapshot itself. This tree is going to be your top level directory, so that is essentially your project. So now that we have these data structures, how are they stored? So like I said, Git defines in general terms an object, throw out any specific language that you have in mind, and it is a blob, a tree, or a commit. And then all of these objects get stored in what's called a content address store, where the key is the string, and that string is the SHA-1 hash of the object itself. And remember, a hash is just a way to take a big piece of data and turn it into a fixed size string. So you can imagine that if we are trying to set something in the store, we can define our function called store. We pass it the object. Git will compute the SHA-1 hash of the object, and then that hash value is the ID. It takes that ID, sets it in the store with the value as the object itself. And then it's nice because to retrieve it from the store, you can retrieve things by ID, so that's very efficient. And this really is just like a way that you can name things in a way that is deterministic based off of the content of the thing. That's essentially what a content address store is. Any questions so far? I hope I can answer it.
Is the blob like the changes, or is it
No.
the entire file structure?
The blob is the contents of the file. It's an array of bytes, but the array of bytes is the contents of the file. Anybody else?
And then the tree is the folder.
Yep, the tree is the folder or the subfolder. So based off of what I have on the left side over there, like I might have misled you guys a little bit because you see where I have in the commit object, parents is an array of commits. It's not actually the commit objects, it's gonna be the IDs. So parents will be an array that either has 1 hash value or 2 hash values. And in the snapshot, it's not actually the tree object, it's just the hash value that corresponds to the top level tree object. And this is essentially Git's on-disk data store where objects are referenced by their SHA-1 hash. So the 3 types of objects, the trees, the blobs, and the commits, they have relationships with each other, and those relationships can essentially be looked up in this store. So this diagram represents that nicely because each blue dot actually represents a commit that's identified by its hash, and then you can see the relationship between the different commits. This is the first piece of data that Git maintains internally, is this object store. But hash values aren't very convenient for people, obviously. So Git maintains another piece of data called references. References are a string-to-string mapping, and it's a human-readable string that maps to a hash value, which is also a string. There's a couple of noteworthy references that you get. The first is when you initialize a project, you're going to get the master or the main. It's really not special from any other branch other than the fact that it has a default name and you get it when you init a repo. But there is another special one called head. And head's a special reference that essentially tells you where you're currently looking right now. So most of the time, head points to a branch name. And when you add a new commit, your branch reference is updated to point to it, but the head will remain the same. So when you change branches, head is updated to point to the branch that you've switched to. And in these scenarios, head is typically going to be the last commit of the current branch. And that's going to be your attached head state. It's like your normal head state. Detached head is when the head starts pointing directly to a commit instead of to a branch. When you're in a detached head state, you can pretty much do everything like you're in a normal branch, except it's all just experimental. So if you want to discard your changes, then you can simply use the Git Checkout to go back to the attached head state. Or if you wanted to keep the commits that you made, then you could create a new branch, and at that point, head would be pointing to that branch, and it would no longer be in a detached state. So it's important to note that the way that Git maintains history, the commits in the object store on the left cannot be changed because the hash value represents the contents, right? You can't change the contents without changing the hash. So that's how Git is enforcing data integrity, essentially. You can add objects to it, but you could never say, I want this commit hash to point to this other commit object. Like that wouldn't make any sense. But references, on the other hand, are mutable. So if I wanted this bug fix branch that I have here to point to a different object, then I would just point it at a different commit hash. And there's also ways to like add or remove references. Does anybody want to try to answer why we would want to mutate references? Like, why is it important that references are mutable versus object store is not? Yes.
Whenever we're updating a branch, wouldn't we want our reference to point towards the latest commit in that branch?
Mm-hmm.
Oh, thank God.
Nailed it. Yeah, right? So, and another common example would be like if you want to switch branches, your head, instead of pointing at main, head would point to bug fix. You could also like rename a branch, or maybe you want to check out a different commit. Which would be, again, in that detached head state. So, also a fun fact about Git Checkout, it actually does 2 things. It's going to mutate the references object, but it's also going to change the state of your working directory. So that's why Git Checkout does so many things, which is one of the things that I love about Git, is like you have this command, right? And you're like, oh, it seems so simple, but you can also use Git Checkout to like throw out your working directory changes. You can use Git Checkout to reset the working directory to a different commit. You can use Git Checkout to update the references, which is essentially changing branches. So in essence, every Git command actually corresponds to either mutating the references or to adding objects to the object store. And we just talked a little bit about the working directory, but I want to take a minute and talk about like your flow. right? Like what are the different states or stages that you can be in when you're working in Git? And the first is the working directory, which is when you check out a repo, it's loaded to disk, and at that point you can modify or use the files. And then the next thing that you have is your staging area, which is how you tell Git what should be included in the next commit using the git add command. And then lastly, we have the Git Directory, which when you clone a repo or if you git init a repo, you'll notice that if you guys ever like look at your hidden folders, as soon as you git init a repo, you'll see this hidden folder with a .git. And that is essentially where Git maintains the data that I was referencing earlier. It's all in that folder where the files are going to be tracked. And also notable, it gets very efficient, so it actually uses delta compression. I'm not going to go like too deep into that, but I'm talking at a high level, and Git does a lot of other stuff to make sure that it's very fast. So normal flow, you check out a branch, which loads the file to disk so that you can use or modify it. And then as you're editing files, Git's going to see them as modified because they've been changed since the last commit. Then you can use the git add command to stage the changes, which simply means that you're marking specific changes to be included in the next commit. Notice that I'm saying changes, not files. That's one of the differences between the centralized models and even BitKeeper is that they track things on a file-by-file basis. Git does not care about your files. It cares about the state of your repository as a whole. So that's why you can see the same file name in the working directory as modified as well as in the staging area. And the staging area can be skipped. It's really just like a developer convenience to give us granular control. Because you can imagine as you're working in your working directory and you're working on a feature, but then you find a typo and then you find a bug, you don't want all of that stuff to have to go into the same commit. You want a way to pick and choose what goes into each commit, and that's the type of granular control that having this staging area allows you to have. And then lastly is as you actually make a commit, then that content address store is going to get updated in the hidden Git folder. So now that we've talked about adding, staging, and committing changes, naturally the next topic is merging. And I'm sure you guys all use Git, so you're probably familiar with the basic three-way merge. Notice here that we have our main line of development going through C4, and then we have a branch which is not branched off of the most recent commit in the main line, but it's branched off of a previous one. So it's a non-linear history. And the way that Git will handle this is it's going to, if you're on the main line of development and you say git merge issue 53, it's going to create a brand new commit, and that is C6 here, and then that's going to include both C4 as well as C5. So three-way because there's a new commit. And then the other option that you have is what's called a rebase plus fast forward merge. And you can do a fast forward merge when all of your previous commit history is the same. So here we have C0 through C2, and notice that our branch, which I have in like the light blue to indicate that it's no longer there, C3 used to have its parent set as C2. But I need a linear history in order to be able to fast forward the master branch to the latest commit. So I rebase my branch on master, which basically says instead of having C3 have C2 as its parent, have C3 have C4 as its parent. And then fast forward just means I'm going to take master, and now I can just slide him all the way to the end. It's like a nice visual. So those are your two options for merging, and it's kind of dealer's choice, but I will say that in general, I believe the use case for fast forward versus like rebase and fast forward versus three-way, if you have a very small bug or a very small feature, it's just like a commit or two, then at that point you might want to rebase and fast forward. But if you're working on a large feature that has a complex history and you want to maintain that history so that future developers can go back and easily identify those specific commits with some large feature, that would be the time that you would use a three-way merge because that history is going to be maintained for the branch. Okay, so kind of like to wrap everything up, I have like a little bit of a demo to walk through that's relatively short, but if you guys have any questions, then feel free to stop me like where I'm at rather than waiting for me to keep going because I'm not gonna probably like rework the history to answer questions. So here I am, and I just created a new directory called test2, and you can see that it's an empty directory. ls for me is alias to ls-la, so it is going to show like all the hidden ones by default. So just know if you're ever doing this, you will need to do the -la option. But you can see that it's not initialized as a Git repository. But if I run git init and then check, now I have this hidden Git folder that I talked about earlier. If I go into this folder, you can see that we have the references, which is the references object, that second piece of internal data that we talked about. And then we also have objects, which is that object store that is the content address store. We also have head, which is the special reference that we talked about. And I'm not going to go like too much deeper into that because it is a little bit more detailed than I told you guys about, but like that's the basics of it. Those are the two pieces of internal data, and then you have your special reference. So at this point, my directory is empty. I have no commits. If I do Git Status, no commits. If I create a file and then do Git Status, you can see that it's an untracked file. If I do git add, git commit message, and we'll just do some trash like thing. At that point, I have made my first commit, and so Git Log Graph one line, it's just some like flags that you can pass so that you can see like the graphical representation of a Git history. A lot of IDEs have this built in, especially if you're using something like WebStorm, it definitely has it, or Git Kraken also has like a really nice UI, but you don't need those fancy paid for tools in order to see the graphical representation. So here I just have my single commit, so it doesn't look too special yet. And you can see I've got my head reference and it's pointing at my main branch, and then my main branch is, or my main reference is pointing at that commit that starts with C0DA-B70. If I make a change and then I do it, or wait, sorry, if I make a change and I add that to the working directory, and then I do it again, then we can look at the status. And here you can see that I have changes that are to be committed. So these are in my staging area. And then down here, I have the ones that are not staged. So they're just in my working directory. So Git Status is a command that you guys probably use all the time. And it kind of takes a lot of real estate up when you're looking at your terminal. Like, I don't really need this. Git Status is like a super common thing to use. So it has a flag, -s, or the long way is -- short. And instead of seeing all of this, it condenses it down to this one little line. So this line has two columns. You can see there's a green M and there's a red M. They both stand for modified, but the left-hand column is, it represents the staging area, and then the one on the right represents your present working directory. So it's just a nice condensed way to see your status. Going ahead and commit everything. And then at this point, if I look at my log, I have two commits. If I take this commit hash right here, and I run one of Git's plumbing commands. So you have your commands that you use, but Git also has some commands that are used for just kind of like poking around, and you're not going to use it if you're actually just using Git on a project, but if you're more curious about Git, you might run these. Git catfile -p, I think the P stands for path maybe, but if you give it the hash, it's gonna give you back the data that hash is representing. So this looks like a commit object, right? Like we have the tree, and the tree has a value that is the hash of the root level directory. The parent is just the one single hash because it's a linear commit history, and then we have some metadata. So this is a commit object as represented by Git and like how it's storing it internally. Then you can kind of keep going. So if you start grabbing the hashes and going down, so I just took the tree's hash, now I have a blob. And remember that I said the blob is the string to string mapping, where it's going to be either the file name or the directory name. So we've got the file name in this case, and we know it's a blob, and then this is the hash of that blob. And then I can do it again. And at this point, I get the actual blob data. So this is just the contents of the file, because I just echoed into this file 3 times. So again, you probably would like never use this, but hopefully it kind of concretes in your head the idea that we have the commits and then the trees and then the blobs, and you can actually traverse this tree in Git, and that's kind of how Git works like internally. Looking at the log right now, we've only been working in main and we have a linear history, but if we check out a branch, Git Checkout B, the -B is just a shorthand way to get branch and then Git Checkout. So I'm creating the branch and then also checking it out in one command instead of 2. And then if I make a commit, wait, sorry. And now I come back and look at my history. It still looks linear, right? Because the feature branch just got its parent is the main branch. So I have a branch, but it appears to be linear. And you can see that my head is pointing at the feature instead of at main. Things can get a little bit more interesting. Oh, one other thing to point out. So here I am pointing at the feature, but if I wanted to go into like a detached head state, I can check out a specific commit and it gives me this nice little message saying that I'm in a detached head state. I can look around, make changes, whatever. But again, if you make any commits, unless you create a new branch off of this detached head state, all of those are just gonna get totally thrown away. And if we look at the log, at this point, you can see that head, it isn't pointing at a human readable branch name anymore. Now, the only thing that head has is this hash. So that is essentially a detached head state. Head is no longer pointing at main or feature, is pointing at this commit. So all of that stuff that I was just doing when I was typing a bunch of stuff was trying to get prepared to show you an interactive rebase. So this is a little bit more interesting, right? Like what I just showed you was a linear progression, but had I continued to make commits and branches, you could have ended up with something like this, where you have your original commit, and then we have one branch called bug, and then we have another branch that's called feature, and then in our main line of development, we have this additional commit, which is where our head is pointing right now. So one of the reasons that I love interactive rebase is because I can go and just like do a bunch of work in progress commits and garbage commit messages, and no one literally ever knows that I do this because I can interactive rebase them to clean them up before I push them. I do want to point out that interactive rebase, it essentially lets you run a script and it replays the commits, but letting you make changes. So remember that I said that those objects are immutable because the hash actually represents the data that is the value. So if you do interactive rebase, it's gonna change the hashes and you're gonna have to force push if you're working with a remote repository. So interactive rebase is really just for if you've just made a bunch of stuff and you just want to clean it up before you push it, but you're not actually changing the history that already exists on the remote. That would be a good scenario for it, because otherwise you're going to confuse people because they're going to pull and they're not going to be able to pull because the history will have diverged from what they have locally. So for an interactive rebase, here you can see these are the commits that are in my feature branch. And interactive rebase takes an argument that is the commit that you want the rebase to have as a parent. So that's going to be this last commit that happened in the main line of development. So I'm going to copy that commit hash. I'm going to check out the feature branch and then git rebase -i is short for interactive. and I'm gonna give it the hash value that I want to be the parent. So this is Git showing you the script that it's gonna run. The script runs from top to bottom, and it gives you a lot of helpful information down here. So you can see P is for pick, which means we're just gonna use the commit as it is. But looking at these commits, like they're really messy. Like I have feature work, more feature work, I have button and card, which kind of seem like two separate things, and then I've got more feature work. So I want to clean this up, and the way that I can do that is, oh wait, am I frozen? Hold on. There we go. So I'm gonna pick the first one because I want that to be my base. I'm going to, S stands for squash. You can see the definition down here. It says it's going to meld it into the previous commit, and I really like that word because I imagine it just like turning into goo and like getting like sucked up into the first commit that happened. Then this one, the button and the card, I'm going to edit that commit. And then this more feature work, I can't squash it because I don't want it to get sucked up into button and card. I want it to get sucked up into the feature work that is at the top of the script. So for this one, YY for copy and them, DD for delete, and then the arrows don't want the same. And then capital shift P for paste. So at this point, I'm just moving this commit so that it actually falls in the order that I want it in. Where did it go? It's back. Okay. And at this point, I can squash it confidently. I do want to point out though, if you're moving your commits around, like Git is going to replay the commits in the order from top to bottom. So if you do something that doesn't make sense, like if I had changes in this commit that I moved and they relied on changes that were in button and card, that would be bad and Git would not know what to do with it. So, but I don't think I do. So at this point, I'm just going to squash this one. And then X to save the file, which is going to start running the script. It's going to pick the first one, and it takes me into this like nice little editor where I can say this is my feature work, but then the rest of this stuff I don't want, so I'm just going to delete it. And then X for saving. At that point, I just have my feature work. And now you're like, whoa, what happened? I'm like back in my normal terminal or whatever. But notice that we're actually still in the rebase. So if I do Git Status, just to like double check it, have this red message that says interactive rebase is still in progress. And then it actually lets me know that these are the last two commands that were run. So at this point, my button and card commit has already been committed, but I want to split them up. Does anybody have a suggestion for how I can split up these commits, this one commit, into two? No? We talked about head. Okay, so at this point, it's already been committed, but I want to take the head and I want to move it back one because I want these changes back in my working directory so that I can split them. So reset. I want them, yes.
All right.
Yeah. So reset has a couple of different options, but if you just do it like normal, this is going to be a mixed reset. There's also a hard and a soft option. The mixed reset is going to update the references object to take the head pointer and point it back one, but it's not going to destroy the changes in my working directory. It's going to leave the changes in the working directory versus a hard would destroy them. So now Git reset head, ~1 for back one. If I do Git status, I now have my button and my card back in my working directory, and now I can commit them separately. Now if I do Git status, it lets me know that I have nothing to commit, my working tree is clean. So at this point I've made all the edits that I want, like everything's back to committed, and I just want to continue on with my rebase. Git gives you helpful hints here. So rebase continue, just like it suggested. And now it lets me know that my rebase is essentially done. If I do Git status, I have nothing to commit. I'm just like back to a regular old spot. And I can check out my log and see that my rebase, like you can see it here. So now I have button and card is separate, and I have all my features squashed down into one commit. So this is like so much cleaner. And I'm still kind of in the spot where I have my bug branch hanging out, and then we might want to keep a feature separate and do a three-way merge for that. So if I go back to main, at this point, I can git merge feature. And this is that third commit, the three-way commit. This is the third commit that Git is going to create. That's essentially just like an automatic, like gives you this automatic merge branch feature. You could change that if you wanted to. I'm not going to. I'll just save it. And then if I look, I can see that now all my feature work is like nicely here in a separate branch, and then it got merged in with this very explicit message. But I still have my bug branch hanging out. And this is just like a little thing hanging out by itself. Like it doesn't really need a branch. So I would rather rebase it on master or on main, which means that instead of bug having this as its parent, I want bug to have this as its parent. Because at that point, I'm back to having a linear history, and I'll be able to fast forward so that it doesn't have to create that third commit that would be representative of the three-way merge. So now if I git checkout, is that what I called you? Yes, git checkout bug. Then I rebase on master. Notice that before I did an interactive rebase, which took me into like the little editor that let me run the script. Git rebase master is simply going to change the parent of this commit. Ooh. Oh wait, sorry, main. And now, looking at the log, you can see that my bug branch is like just linearly right here on top of main. So now I just have to merge, but my merge is, Git is smart enough to recognize that because all of the previous commit history is the same, it's just gonna do a fast forward. And you can see this little note here saying that it did a fast forward. And now I have my head pointing to my main branch because main is the one that I have checked out, but main and bug are both pointing to the same commit. So it's just a way to clean up your history. That was my demo. Does anybody have any questions?
If you had to rebase a lot of branches, would you do that by script somehow?
Jordan?
I've never done that. I probably would try to do it with the script or not do it.
I don't know. I would be like really hesitant because I just like the granular control. Define a lot though.
I work in the back end and I just turn it in for PR, and the guy that he merges it into master, my stuff, but then he has to rebase all the states.
So one thing that you'll run into when you're rebasing, it's essentially giving priority to whatever branch you're rebasing on. Like I just rebased on main, so it's giving priority to main. So were there to be a merge conflict, then I would need to fix that merge conflict after rebasing, or like essentially I would rebase, and then when I went to merge, if I had conflicts, they would show up there, and they would show up as like the new branch's fault, not main's fault.
Right, my name's Ryan Harrigan. This is the intro to React. Thank you for Tampa Devs and ReliQuest for putting this together. Really appreciate it. Quick survey. How many of you all have 2 years or more of front-end experience? Front-end, about half. Chat. Raise your hands if you want interact chat. Great. How many of you just took recently a front-end course or boot camp? Great, cool. And who wants to learn React? Great, cool, nice. All right, a little bit about me. I've been a web dev for a while. I work at a company called Sugar CRM, and I like to do hackathons. I just started getting into Next. I like Next. I make some websites. I'll show one for a demo hopefully later. Here's my LinkedIn. So we do have at Sugar CRM, we do have open positions. Hopefully we're not. We're California based, so software engineers and data scientists, stuff like that. All right, so what is this talk for? Really, it's anyone who's trying to go from zero to hero with React. It's going to be a little bit of fire hose for everyone, so especially within the amount of time I'm going to cram it into. So let's strap in. All right, so what I've noticed, one thing, I'm going to cater to the kind of the uninitiated of React people. What I've noticed when I've talked to a lot of students and stuff like that, they're kind of learning JavaScript as well as React at the same time. So I'm going to try to take this first section and just kind of break down some things that you can at least make sense of while you're trying to also cram through React and JavaScript at the same time. So what we're going to cover, business reasons for React. I'm going to skip past some stuff. We're going to give a demo. I'm not going to do any React Native or React other stuff. And maybe I'll just make some suggestions or have an open question at the end. So why React? It's really simple. It's because it's simple. It's very well documented. A lot of people use it. Businesses, as we know, JavaScript is taking over the world. So it's a good choice for businesses because people can learn it, and it's within the wheelhouse of new greenfield projects. So it's good for that. JavaScript, yeah. JavaScript was also made in 10 days, but compared to Git, you know which one's better. Library versus framework. Anyone does not know a difference between library versus framework? Anyone have any questions? Yeah. So
I don't know.
So framework. This is all code. They're both sets of code, but one is more of like a framework makes decisions for you, makes conceptual decisions, strategic decisions, and a framework is just a collection of kind of tools. Usually libraries are smaller than frameworks. Yeah, a lot of junior web devs are learning at the same time. I'm going to just show some JavaScript stuff. And here's my advice: if you can, don't use class-based components. So for this talk, we're all going to use React hooks, just for the sake of convenience. Here's what I'm going to go through. So let me just kind of show some things. I'm going to bring up a dev console here. Here's Zoom. So let is a thing to make a. Well, let's start with var. Var is a way to make a variable. Variable equals
Can you
1.
make that bigger?
Maybe. Yeah, command. I don't know. Yeah, there we go. Is that better?
Nice.
Yeah.
Thank you.
Yeah.
Too big.
Yeah. Sorry, chat. Not doing React Native. All right. So ways to make variables. Var. Same thing with. You can do the same thing with let, except that let does not allow you to declare a variable. You could do var a couple of times, but let and const are better. The difference between let and const is const you can't change the did I just change? Yeah, it's variable 1. You can't change the variable 1 equals 2. You can't change the actual value of the variable. All right, getting back to this. Arrow functions. So we use a lot of arrow functions in React. So like if you're looking at JSX and all this other stuff, arrow functions are going to be something that you should get used to. So let me just kind of show you what that is. It's really just a way to show the same. You've probably seen function blah 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 equals block of code. An arrow function is simply syntactic sugar for that. So const my arrow equals nothing, and we're just going to wrap this in curly braces. Console.log. I did something, right? So you see that I declared it, nothing happened, but if I were to call my arrow, it'll do all the stuff in the blog. So that's just an arrow function. Let's go next. Destructuring. This is something that's used a lot in React as well. So if we have an object, props. A lot of data is sent through something called props, and that's an object in JavaScript. So if I make an object, I'm just going to call this props. We're going to have height 200, width 300. Right, so that's my object. If I show props here, it's an object, right? A way to destructuring is basically a syntactic way of pulling those attributes out of the object in a simple way. So if I put the syntax looks very very similar. So that's a wonder of JavaScript, but you can see that it's kind of backwards here. But what we're doing is that I used that const declaration to basically create a height variable and a width variable. So if I were to put height, it's now an actual variable that I can work with. Same thing with width. All right, moving on. It's immutable. I just started with it. Okay. You can do the same thing with arrays. Spread operator is a. I'm not going to go into that, but it's another way of making objects. One really cool thing I use a lot in React is optional chaining. So we saw that we have a props dot, we have a property here, but what if we just tried to call an attribute on, or try to read an attribute on the object that doesn't exist? We're going to get, most likely in React, we're going to get an error. Here, z is undefined, but we do z dot whatever width. You'll see an error here. Optional chaining is something that we can use where it will kind of safely pull that out of the object, so your React won't get the crash and you won't get the white screen of death. So JSX, I'm going to skip that. React developer. So if I could just kind of stop from all the syntax stuff and just kind of give you a summary of my daily life as a kind of a front-end software engineer. I see a lot of JavaScript is obviously very popular. It's going to be is being adopted into a lot more code bases, so that it's being more critical in the software development lifecycle when you're making production-ready applications. So JavaScript obviously is probably being used in the browser, so it's a lot more readily observed from everyone than backend. Backend's always kind of like extracted, so you kind of have to work with that team pretty much every day. Yep, and I think Lydia kind of went into some of the PM stuff, or practices with your team. So React hooks. So now we're going to get into a little bit we're going to get into the meat and bones in React. I have an example here. Can everyone see this?
Can you make it bigger?
Presentation mode, probably. I forgot the shortcut for presentation mode. Anyone know the shortcut for
It's up in view.
Oh, yeah.
Shortcut for what?
high floating media controls, view, presentation mode, code?
You might want to blow that up.
Oh, this is WebStorm.
Oh, that's WebStorm.
Is it? Yeah, I tried this, not really showing.
What about HTTP?
Whoa.
Do view appearance. Do it that way.
All right,
Man.
sweet. All right, so thank you for that. This is a component. This is actually a minimal React Code for Orlando demo. This is kind of like a minimal React setup. So with every JavaScript thing, you're going to have package JSON. I'll try to make this available, and I'll post this to this demo to the meetup event, so you can all use this. But React is a pretty simple thing to set up. Here we have package JSON, but what this really does is that it starts with an index, HTML. Everyone knows HTML, and there's a div here with an ID, and it also loads in a bundle script. So with the package JSON, I'm going to run a script that makes that bundle.js available for this index HTML. When that runs, what it's going to do. Where's the other JS one? Oh yeah, it loads this app.js. This app.js runs, and what happens is that here's that constant, and this is a component, and all components are these arrow functions. So let's forget about this component for now. What this JS thing does is that it takes a render. It basically looks for that anything available to it. So when the JS bundle loads, it looks for an element and then binds all the React stuff to that element. So here, what I'm doing is I'm binding this component, which is my app component, to the index. So essentially, if I were to run this, right, this is what the package JSON shows, and we can go to our local and see that my component runs. So basically within here, I just show some text. All right, so moving on. That is a fire hose thing for at least building up a component or building up a React application. Use state is one of the first React hooks that you use, and there we go. What we're going to do with this use state is make a counter. Actually, I will go through just a few hooks now that I think, since we're trying to do time, since we're trying to be courteous of everyone's time. I showed you the component. I'm going to show you use state, and then use effect, and I'll stop there. All right, I have a whole thing after this, but all right. So we have a use state that we want to use. So here I'm going. Use state is at first I gotta import use state, right? And here I'm going to use the array destructuring. That's the way how this usually works. So I'm going to say value and then something called set value. So what this does is in this variable value, whenever basically every render, like which happens many times a second, if something changes, these variables will be declared, right? The value will be declared, and the set value method will be declared from this use state. There's some smart things that go under the hood to make sure that it runs performantly, but we have this value, and we set this initial value to 0. So if I were to make a label here, div value is value. We're going to now run that. I'm going to go over to my other thing that I had going on. Yarn start. All right, that's running. So we have value is value. Great. So use state works. So what if we want to do now that's actually cool, but we're not doing anything with that use state. So we are going to not make a whole fizzbuzz thing. We are going to basically change that use state on click. So here I have a little button here that just says click. I made some styling on it. Forget about the whole styling. It's really just your friendly div, but in a React JSX environment. The way we set an on-click listener is through this reserved property called onClick, right? And I'm going to make an arrow function here. Oops. You notice that the arrow function is within these curly braces, and I'm not going to take in any parameters here. Usually, it's just the event, the common event for this onClick. So what I'm going to do is I'm going to use this set value, and I'm going to basically add. I'm going to set that value to this value plus plus. Right, so whenever we click on click, we're going to, what is it complaining at me for? Whenever we click that button, this value basically goes up. So that's great. But, if I refresh the page, all the JavaScript memory just basically goes away. So if we wanted to do some other things, use effect is kind of like another staple thing. So great, we have some interactivity, but what if we wanted something to happen? What if we're building a game, a click game, and the user clicks more than 10 times? We want something to happen. So that's where use effect comes in. So here I'm going to use effect. Use effect does not set anything. Here we're going to have an arrow function, and that it has dependencies, and this dependency is going to be basically these value and set value. So if value or set value were ever changed, the logic within this use effect thing will run. So I could say console, or I could say, let's just do alert. You clicked modulo 10 times, right? So if value modulo 10 equals 0, then we'll alert. All right, so we have some custom logic here that runs basically on whenever we click stuff. So this just loaded 0's modulo of 10. If we get to 10, this works. So we're kind of building these interactive applications, and there are just a handful of other hooks that React does, but That's it. That's really it. There's some advanced stuff, but if you all have any questions, you can kind of reach out to me. I'm on the Tampa Devs meetup. I'm on LinkedIn, so please just reach out to me. Does anyone have a question so far?
Why do you need use effect for this game? Why don't you write this without use effect? Just
Yeah.
publishing it?
We're building, so when you're building a UI, you're building something interactive for the browser, right? And use effect basically, you could calculate. React renders a lot of things. Like there's always things changing in your browser, and to basically save on performance, or to save your performance without calculating all these things all the time, use effect really just looks at the changes and see and if any of the inputs do change, like these variables here, then your block of code will run. You could have hundreds of lines of code that do other things, right? But as long as these dependencies don't change, or as long or it's really just checking out those dependencies. So it's basically a performance thing, performance saving thing. Great. Thank you. Tailwind is better than Bootstrap. Don't ever use Bootstrap. And great. Thank you. Have a good night.